Let me share my screen again. Okay. It's better to go to the first chapter and see that if we can cover this part. It described about that what is data mining and why we need the predictive analytics and why we need the statistics. In the book was discussed that data mining is the process of discovering useful patterns and trends in large data sets. So the main idea is finding the useful patterns and trends, okay? And it said that the data mining is related to large data sets, not the small data sets. Because in a small data sets, mainly we talk about sampling. And in sampling, we have a lot of statistical methods that they cover everything for more than 80 years. They are working on this kind of things and they cover everything about sampling. So the problem that we have now is about mainly the large data sets, okay? So the data mining is coming for that. And what is the difference between data mining and the statistics? That's the good question. And the predictive analytics also is something related to data mining, is similar to data mining, but it is for prediction and estimates about the future. So it said that the difference between the predictive analytics and data mining is that data mining is studying the situation that we have now, and for predictive analytics, we are interested in future. Okay, so I found this charts very informative, so I wanted to share it with you. That you can see that for data mining, there are some skills that we should know, and we should know about it for the artificial intelligence, of course, and for machine learning. So the concepts are the same with this chart that we have here. Here we can see that we have to know about the statistics if we want to have any of these skills, okay? So for data business person, for data researcher, for data developer, for data creative, we have to know statistics. So statistics is the base. And as you can see, they put it in the bottom. It means that it's the base. So for each of them, we need different amount of knowledge of statistics. And then we have to know about programming and also the mathematics or operational research. And then we have green, the machine learning and big data, and then the business. So the main important part, in my point of view, is this business, because we already know about these parts, but the business is something that the people don't talk about it so much. The knowledge of the business can help us to know which model we have to use or how we can treat the data when we have some difficulty in the data set. Okay, so if the data is not so clean, the business can help us to give us the information, how we can clean it, how we can deal with the problems that we have in our data set. So the business here has a lot of functions, even when we want to present our results, okay? We want to design a kind of dashboard, a kind of BI outputs, then we have to know the language of the business, because we want to transform our knowledge from the model to something that the people in the business can understand. So here we can see that the business is playing a role in all of them, and also the statistics, and between we have the machine learning, big data, programming, math, and so on. So here, where is the data mining? Is there any idea?
Not exactly. Mm-hmm. It's definitively statistics.
Yes, exactly. A part of data mining is coming from statistics.
Data researcher? No.
The rule, you mean here, data researcher. So all of these rules, all of these skills that they put here, they need the statistics and data mining, okay? So we have data mining, but it is somehow hidden in this graph, okay? A part of data mining is here in statistics, and the other part, as we said, that data mining is working on the large data sets. Okay, and the large data set is not necessarily big data, but it is close, right? So we have data mining here also. So the people say that, what is the data mining really? The data mining and machine learning, what is the difference between these two? And the answer is the data mining is the analytical tools that we use and we have in our toolbox, but it is more lie on the statistics. Okay, it is going close to a statistics. And what is machine learning? Machine learning is the same, but it is going more to the business. Okay, so the machine learning is going more to this side, and the data mining is go more to the pure part. So we have these two words for one thing. Okay, uh, this is something that can make clear the difference between data mining and the machine learning. And here I want to give you a kind of overall information that what we are going to do in data mining and what is the main purpose when we are talking about machine learning. Okay. Are you agreed to go further? Anything to add? Please interrupt me anytime, okay? Nothing?
Nothing.
Okay, so let me explain this graph. This is the real target model. What is this? This is the real world, okay? This is what we are seeing in our daily life, okay? All the stochastic processes that they are working in the world. Why we talk about the stochastic processes? We talk about normal distribution, we talk about probability, calculating the distance between 2 points and the probability that 1 point drop in one section or in one cluster. Or recently we had the Bayesian methods for calculating the probability. Why the probability is important? Do you have any idea that why we study probability here?
To get more closer to the real outcome?
Exactly right. Yes. Any more?
We think that the pattern is that the historical pattern is going to repeat over time.
Yes, so we have some correlation between the data and we can anticipate, we can forecast something if our goal of a study is forecasting. That's all true, okay? But here in the real world, what happens if we don't have probability? If we don't have probability, it's chaos. But there are something that they are completely certain, okay, and we know about them, but they are not something random without any pattern, okay. If we don't have probability in one problem, okay, or when we don't have probability, we mean that probability is 0 or 1. It means that that event is going to happen for 100%, or it cannot be happened, never ever in the world.
Then it's the absolute opposite of chaos is certainty.
Certainty, exactly. And here, when we have this situation, there is no model there. We don't need any model. We observe it only once and we have all information, okay? So this is the point. If we don't have probability, everything is clear for us. But if we have probability, the people start to ask questions. What would be the future of this? What would be the model that can discuss it for us? Because we cannot understand it. Sometimes it is happening, sometimes it's not, and we cannot understand it. So here, one important point is that if we don't have probability, we don't have any problem to solve. So the modeling and the data mining and machine learning is starting from this point that we have probability in our problem, and we want to make a model to deal with this probability, okay? So here, in the real world, we have a function based on the probability that we want to understand it. So we don't know anything about this real function in the world. It is a kind of function that is working. We don't know anything about it. We can only guess something. How we can guess it? Based on the probability theory, based on the mathematics, based on the statistics. So here we can understand the rule of the statistics. Why we need the statistics? Because here we have something in the real world that we don't know about it. It is completely random, and we want to understand it. How we can understand it? We have to put it on the paper. Guys, everything that we want to solve in the real world, we have to put it on the paper. If we cannot write it, we cannot solve it. So writing the things on the paper is very important. And mathematics is the way that we can write everything on the paper. So statistics is coming for this, to write the problems that they are related to probability on the paper. So if we can't do that, we have some suggestions here, okay? We have some suggestions that it gives us some clue that how this function in the real world is working. We select one of these candidates as our function, and then we calculate the distance, this distance between the function that we guess based on statistics and mathematics and the function that is in the real world. Okay, that's a nice story that we can get a kind of approximation for this function, but you said that we cannot see this function in the real world, so how we can get something about it? What is your idea? If we cannot see this real function in the world, can you see my mouse?
Yes.
Yes.
Okay. So if we cannot see this real function, how we can make some candidates for that?
By comparing what we are predicting to what's happening, considering the variables in our model.
Yes,
Like,
you point something very important. The things that they are happening, okay? So we can see what is happening in the world. We cannot see the function, but we can see some effects. What we call those kind of effects? Can you guess what is that?
Observe data.
Observed data, exactly. So the things that we can see from that function, that real function is data. So this is the reason that the data is important. People are all talking about data. Why? Why data is important? Because data is something that show us some effects about the real function from the real world. And because of that, this is important. So we cannot see the function, but we can see the data. The data is the effect of this function in the real world. It can be the behavior of a customer. It can be some effects of a drug. It can be some effects of a disease, something that we can see. And based on that, we try to guess family of the functions that they are close to this function. And then we work based on the statistics, data mining on those functions and make a function close to that function that we are looking for, okay? And this is the distance between these two. We want this distance to be very small because we want it to be exactly this one, but we cannot do that. In the real world, this is the probability, okay? So it's not exact. And we need this to be close to this. Any question by now?
No.
Okay, so let me discuss very briefly the rule of the data science, pure sciences and applied sciences, the data mining in the whole story of the data analysis. From the first part that we get the request of the market to the last part that we deliver some information. So here we can see the pure statistics. The story starts from here, okay? So basically, the needs and the requests from the business is not going directly to this part, to the, let's say, data science or the applied sciences. It comes to the pure sciences. And then the pure sciences like statistics, mathematics, computer science, that they are in the faculty of the science. They work on the problem and they make some theory for us. Okay, so we have some theories. These theories will be conformed to methodologies, that the methodologies are the applied part of the theory. We can say that the methodology is how to apply the theory in the real world. So we make some methodologies here. We can use the data to make the methodology and also the theory. From the methodology, we make some algorithms. So the algorithms are coming from methodology, and methodology is coming from theory. Okay, so we start with pure sciences, then the applied sciences work on the theories and make some methodologies, and based on the methodologies, we have some algorithms. Basically, we see the algorithms. Everything that we are looking at in this data mining course is the algorithms. We don't focus on the methodologies and also the theories. And because of that, you see that the professor said that this is very pure, so we are not going to do math, okay? So take it easy. The math part is not our job. We need only to know how it is working in the real world. So we only want to know about the algorithm. So the things that we are looking at in our classes is algorithm, is not the methodology, and it's not the theory. So here we have the algorithms. We combine it with data structure, and then we make some applications. The applications are coming from programming and the domain knowledge. So this is the business part that we have seen in that slide. Okay, the business help us to make the applications, and then from the applications we make the final product. This is the work of the developers. Okay, the developers are here, the applied science is here, the pure science is here, and overall of all of these parts we can say data science. Okay, the data science needs a little bit to be a developer, a little bit to know about applied science and know about the methodologies, but not actually about the theories. But if you know about the statistics, mathematics, computer science, you know about the theory also. That's a value added, of course. And from this part that we make the business intelligence and some dashboards, it will go to engineering to make artificial intelligence. Any question about this?
No, not really.
No?
It's okay.
All right, okay. Let me start from the scratch. So this is our book, right? And if you go to the first chapter, we are here. What is the data mining and what is the predictive analysis? So the main parts of this page is this yellow parts, okay, that I highlighted them. We have some examples. We start with some examples. So here we have the computer manufacturer Dell. It said that they wanted to improve the productivity of its sales workforce, okay? And then they start to go to LinkedIn and social network, and they started to identify the characteristics of each customer. And because of that, they could doubling the productivity and efficiency of the sales workforce, okay? So it is a kind of application of the data mining, how it can help us. So here we have the definition of data mining that we reviewed it before, and here we have the predictive analysis. Basically, in the statistics, it is the same. So we have some courses that they study the whole data and behavior of the data, and the time is not important. So we don't have the dimension of the time there. We have, for example, descriptive statistics. We have the regression. Okay, in regression, we don't have the dimension of time, but in time series, we have. So time series is somehow related to this predictive analysis, okay? And the other courses that we have in statistics are mainly related to what we call now data mining, when we have huge number of samples. The data mining use the concept of statistical tools that we had before, but extended somehow that they works for the huge amount of data. For example, we have now archive to select the model. Okay, so I put this graph also here because this is not for the book, so don't look for it in the book. But the reference is here. You can see the reference. Okay. Okay, so the data miners are in demand. That's good news. And here we have the direction of data mining, human direction of data mining. This is very important that automation is no substitute for human oversight. This is very important discussion in artificial intelligence also. So we have now the augmented intelligence, okay, instead of the artificial intelligence. And this black box software, this is the problematic part of the story because the people apply the methods blindly. Finally, they said that, okay, this procedure in this language is working for that. And they said, bingo, wow, oh, I found that. So I can go and apply it. But it's not like that, guys. We have some hypotheses for each method that we are using. So if we don't go through it and if we don't check them, we will face some problems. You can find the answer if you apply the algorithms in any kind of data. But that answer is not working. And this is the problem now. A lot of people that they are working on data mining and machine learning in the market now, they are working with the Python or they're producing the models, but actually they are not really working. They are not going to tell them something more than they knew before. And sometimes they make some mistakes and that costs a lot. And because of that, they are going to a little bit backward. They are going to close the doors to the data miners. And that is a really hazard to our job. The black box software is not usable for the people anymore because they see something is wrong with some models and they cannot understand it. And because of that, the caution in the market is more than before. Okay, so we have to take care of this misuse that is very dangerous. So I put a comment here. The main problem is if you run the data mining algorithms, they work even if you are completely in a wrong direction. So there is essential need to have a good understanding of business, the statistical background of the algorithms, the quality of data, and finally the weakness of the algorithm. All right, so here they present the CRISP DM. This is the model. As you can see, they start from the business and research understanding phase. This can be a literature review. So if you want to study on something very new, you can go to the papers, there are a lot of other researchers, and then do the literature review. And then you have to make some data, gather some data, then data preparation. That's very important phase, more than 70% sometimes of the total work. And the modeling phase, that's very simple nowadays with the computational power that we have and the Python and R and a lot of libraries there and packages. And then evaluating, okay? And finally deploying to the market. So this is the discussion about the model. And then we have in this page the passage about the data mining. So what is wrong with data mining, okay? There are some important points. The other parts, I didn't find them very important. There are no automatic data mining tools. So the people that they think that, okay, we put the data in the software and we get the model, no, it's not right. The other thing is blind use of data mining software. We only provide you with the wrong answer to the wrong question applied to the wrong type of data. Here, this sentence, in my point of view, is important. Used properly by people who understand the models involved, the data requirements, and the overall project objectives, data mining can indeed provide actionable and highly profitable results. So the data mining is working only if we have all of these parameters offered to the market. Okay, So here we have the different parts of data mining. We have the description, estimation, prediction, classification, clustering, and association. You know the meaning of these words from the class. The only thing that I want to add here is that estimation in some books is called prediction, okay? But in this book, they called it estimation. And prediction is called forecasting. So if you see the description, prediction, forecasting, classification, clustering, association is the same thing, okay? And in many literature, this is the discussion of this. I already told you, but I put it here that you can review it when I put the file in the group, okay? And here the explanatory data analysis, it's a graphical methods of exploring the data in search of patterns and trends. Any question here?
I have
Yes.
one. Maybe it's the same. You were saying that estimation and prediction is different, or that estimation in some books is called prediction and prediction in some books it's called forecasting.
It's called forecasting, exactly.
Okay. But
Yes.
How can we differentiate one from another? If in some books estimation is prediction, but in this it's estimation and has prediction at a side. Yeah. Sorry, it just confused me.
I can describe it like this. The estimation or prediction, any name that you want to put on this subject, is something about when you talk about a boundary of the data that you already have seen it. For example, the speed of wind and the temperature, okay? Two variables, the speed and the temperature. So you want to, you have seen some points, but you want to see what is happening between. So we have the overall information with some points, but we don't know all of them. And we want to know something in between. So we have to make a model. We have to make a line as a regression line, for example. And then with that regression line, we can put any x that we want and get the y, right? So this is the estimation, or in some books prediction, that when we are talking about a boundary of the data that we have already seen the minimum and maximum of that, and we want to know what is happening between. But forecasting, or here it called it prediction, is something about the future. If we have seen till now, and now we want to know about a part of that function in the future that we have no opportunity to see that, okay? So they called it forecasting, but here they call this part for the future prediction. And when we are talking about the boundary that we have seen it already, they called it in this book estimation. Is it clear?
Yeah, it was a good example.
Okay.
Thank you.
No problem. Anna, have you had any question?
No, but
right.
mainly we are going to see these phases, these tasks, like it's in yellow, right? Or not?
Yeah. Here you mean?
See, yes, like it's in this book. That's what we are going to be asked for and explained to during classes, and not the other two ways.
Yes, these are for the other books.
Yes. Okay.
Yeah. Okay. All right. So here we can see if we are talking about this part till this part, okay, they called it estimation. If we are going to continue this to see what is happening for the part that we haven't seen it already, this is the prediction, okay? But in some books, when we are talking about something in the future, and they call it forecasting, okay? So I wanted only you to know about these differences. If you see in other books these words, don't mess up with the words that you see in this book. And here we have the classification. So the classification, the target variable is categorical. So when the target variable for our model is categorical, we have the classification. So we should have the target variable, okay? And the target variable should be categorical. So we have the classification. At the other part, we have clustering. Clustering is about the situation that we don't have the target variable, okay? And only we want to put our samples into different clusters. Something that is important here is that we had it before in statistics. So clustering and classification is not something new. The concept is coming from statistics. How? In statistics, the cluster sampling was exactly the same that we do now with the clustering. Okay, when we have a dispersed population and we want to take a sample, we use the clustering sampling. So you can go to this keyboard, the cluster sampling, and look at this and make a kind of comparison with this one. And the classification also. For classification, we have a stratified sampling, okay? So stratified sampling is coming from 90-20, 90-40. So you can see this kind of methods and concepts are not new. Okay, so these are two keywords that you can go and look for it. And finally, we have the association rules. This association rules makes only some rules for us to follow and find the answer. Okay, any question about this clustering, classification, association rules?
No.
All right. In this book, we have the R program for this part, so you can go to R and check them. Okay. And now
one question.
Yes.
When I started reading the book, they talked about R, and I thought about starting to work with it right away. But then we had to install SAS, and I don't know if it's useful because we have little time, all of us, to learn R right now, or if it's best that I concentrate in other things. What's your opinion?
What do you think, guys? Do you have any experience with SAS or R programming?
I had not before, but
Okay.
it seems.
Neither have I.
Yes,
Okay.
it seems easy. Not the part of writing the programs, and I'm not sure if using the same code for everything it's a good. I understood that the teacher suggested that we could use the writing already in the Tugas model for other examples, like the project that we have to deliver. Yes, but I don't know if that's so easy. So that part with the writing the code, I'm not, I don't know if, I never tried it before, but it seems very intuitive. And in R, I know that we have to do the same. We have to program, like to write orders to that application. And I have a colleague that is working already with R, and he says he took like a whole day to try things and to start writing the code. And okay, one day is not that much, but I don't know, should I use that day to do that, or should I use it to study statistics or to learn more about SAS? I don't know. Is going to R a deviation of the focus of this curricular unit, or is it a good way to develop the knowledge in this unit. What's your opinion?
Okay, so basically, the difference between SAS. So SAS is one of the best statistical software in the world. Okay, and many big companies are using SAS. There is a very good support, and all of the things that we have in data mining, in modeling, in marketing, very specific methods that they are developed for marketing, for example, or for the other parts of the data analytics, all of them are available on SAS. So SAS is a very complete software with a lot of documents. And I heard from someone that the SAS has not a good documentation like R or Python, that they are open source and they have community, but that is not true, because SAS has the annual conferences and a lot of different workshops during the year, so you can find all of the documents online. You can also find not only the documents and the programs, you can see a lot of examples. So if you have a project, sometimes it's not necessary even to write the text, because the text is also there. So the program is there, the text is there, the description of the output is there. So it's only necessary to go to internet, Google it, your problem with the SAS, and then find the document and read it. That's as easy as this. But for R, we have the document, we have the open source packages that we can use, and also we have some communities. They write many things about the questions that the people ask on internet, and that is also cool. So if you want to apply something for company, for a bank, for an insurance company, for a big, I don't know, market, then the SAS is a good option because you have the support and everything is working well, because they check everything when they change the version. It is very important. When they change the version, they will adopt everything with the last version. Okay, so you don't miss any kind of information if you upgrade the SAS to the new version. But in R and in Python, you have seen in Python, for example, when we had Python 3, the Python 2 was not supported anymore. So the people that they wrote a lot of programs in Python 2, they missed all of them for Python 3. So they had to stay on their estates on Python 2, and they couldn't upgrade. Okay, so this is some problems of the open source programs. But the R is very easy to apply. The comments are very easy. SAS also, the comments are very easy. If you go through the programming of SAS, you think that you are talking with a human being. You are talking with your friend. Please calculate this for me. Because there are some procedures, you call the procedures. For example, for descriptive statistics, you say procedure means variable this, and then run. And it will calculate everything for you. So it is as easy as this. The SAS is like this, and the R also is very easy. If you want to learn something for yourself, for your research, for small businesses, R and Python is very good. If you are going to work for the large companies, SAS is good. So the software is not really important, okay? Only start one of them and start to learning it step by step. The whole idea is important. Knowing the algorithms is important, and how to apply it. We make a method of machine learning. It is published in expert system with applications. So you can go and see the code of the paper, right? The code is there, so yeah, the code is not a problem nowadays. There are many people that they are writing their codes and they are sharing the codes.
I like these kinds of presentation. It summarizes everything. Okay.
Okay.
Good.
Afshin, just one question, Afshin. On the topic of R and SAS, would it be good for someone starting as a beginner to learn about these two tools, to start with R, because you probably have access to the statistical methods in a raw format, and then when you go to SAS, you have it all done in the background for you, so you don't touch the programming. You just need to drag and drop, as you said. So wouldn't it be also beneficial for someone starting to start by R?
Yes, SAS has the voice. So yes, for SAS, for SAS, you have the programming and also you have the drag and drop. So the drag and drop is in enterprise minor of SAS, but you have also the core SAS that you can go and write the program. Okay, so it needs coding, but the coding is very simple. It's not very difficult. You call the procedures and then everything is done with SAS for you. But for R, you have to use the same as the procedures of the SAS with the packages. You download the packages and then use the packages. So you see, they are completely the same. Yeah, and SAS in many years ago, I started to use SAS 20 years ago. So in that time, SAS was working on the help of the software, and they produced something around 1 million pages of the help for this software. You see, this is for the year 2000. And I had my first master, and in that time, that was huge, you know. And in that time, the computational power was not like this, but it was good. We had the Pentiums, we had good servers, and the SAS was working on that time, but the R was not exist. But the idea of R is the open source. R is the open source. So uh, all the professionals are working on that. All the people are that they are professional in statistics. They are working on that, and they are making a lot of packages. And you have the community online that you can ask your questions, and you will get the answer. But if you want to ask the question from SAS, you should pay for that because the support is not for free. But there are a lot of free documents for SAS that you can use. So really, using the or choosing the software is not important at all. Software is something, if you go through the Python or R or SAS, all of them are very easy to learn. They are very straightforward, and also you have a lot of help online or offline. You can find a lot of documents. So don't worry about the software. I think that you should only choose one and start to write your program. And even if you don't know how to write your program, you can go online, Google it, and the people have done it for you before. You can only copy and paste, and this is the way that many data scientists are now data scientists, you know, because everything is online and they have the answers already.
Of course. Thank you.
Welcome, George. Okay, guys, any other question for this session, or we can close this session?
We can close.
I would only like to ask if you are going to send us these slides, or at least the slide where the chapters are highlighted, so that we can see the dates and choose what we are going to present?
Yes, so let me show you here for only 2 or 3 minutes the
Yes,
group.
or I can do a print screen.
No, I will share everything here. I will share everything. So you can see the group now, right? This is the data science for finance, right? So here we have this link that is the link of this class. But if I go through this, I close the comments here because in the main page, we don't write anything. But if you scroll down, you will see the Data Science Online Club here and 2 comments. If you open comments, you can see what we have written here about this book before, okay? Even if you click on this one, okay, you will see that it's going to be open. And you have that page, the page of the book. All right, so this is the page of book. I put all of the materials here, and then you can add the comments. For example, if you want to write something about this comment, you can put click on reply, and then put your question or anything that you like to add here. If you read something interesting and you want us to know, you can come here and add it that the other colleagues can see, okay? So everything is here. Everything would be here, the file, the comments, the notes, questions, answers. And if you put, for example, a question here, for example, maybe Gonzalo has a kind of answer for that, he can come here and then click on reply and reply to you. And I can see, so maybe I have another idea, so I can put my comment and the discussion will go on. That was only the idea that I thought that maybe this group can help us, or this kind of putting the comments can save everything for the future.
I think it's a good idea.
Yeah, it seems good.
It's good. Yeah.